In this video lecture, we shall discuss operator precedence, associativity, and type conversion. The outline of the lecture is first we will discuss precedence and then associativity, and after that we will discuss type conversion. Type conversion is also called typecasting. So first operator precedence and associativity. Okay, so consider the following arithmetic expressions, and there are two expressions, and both of these two expressions involves more than one operator. So first one is 2 plus 3 into 4. Okay, now there are no brackets in this expression, so there is ambiguity which operator is to be executed first. Okay, if you execute, that is if you evaluate 2 plus 3 first, then the result will be 20, and if you evaluate 3 into 4 first, the result will be 40, right? So there is ambiguity in the execution of this expression. So either you must specify which operator is to be evaluated first. Okay, so one way is using the parenthesis, that is you can write this expression using the parenthesis 2 plus 3 into 4 or 2 plus 3 into 4, right? So this expression can be written unambiguously using the parenthesis, but if no brackets are specified, then there is ambiguity. Okay, so in fact for this expression the correct result is 14 because multiplication is performed first. Why multiplication is performed first? Because multiplication has the higher precedence over the summation, right? So multiplication has higher precedence over the summation, so multiplication is evaluated first. Okay, so we need some precedence rules, that is we must be able to identify which operator is to be evaluated first and then which will be evaluated next. Okay, so if an expression has multiple operators, we must be able to identify exactly the order in which those operators will be evaluated. Okay, so this is called precedence, that is we must be able to uh, find the exact order of evaluation of operators in the given expression, right? So a normal rule is, you must have heard about the BODMAS rule. Okay, and in fact in the next slide, okay, so BODMAS rule is, say the normal mathematical operators are listed here. This is for exponentiation, then we have the multiplication, division, and the modulo or the remainder operator. Then we have plus and minus. Okay, sum and subtraction, right? So the exponentiation has the highest uh, precedence among these operators. After that we have multiplication, division, and the modulo operator, and after that we have sum and minus, right? So addition and subtraction are at the same level. Okay, multiplication, division, remainder are also at the same level, and exponents is at the highest level, right? So now go to the previous slide. Now consider the second expression, a divided by 4 into 2. Now the two operators involved in this expression are at the same precedence. Okay, in the first expression 2 plus 3 into 4, multiplication has higher precedence over sum, right? So we can find the order of execution by considering the precedent levels, that is multiplication has higher precedence, so multiplication will be evaluated first and then sum will be evaluated. But in the second expression the division and multiplication are at the same precedence level, right? So then how will you decide which operator is evaluated first? Okay, and in this situation we need associativity rules. Okay, if two or more operators are at the same precedence level, then they are evaluated according to their associativity rules. So in this in the associativity rules, the order is specified as either left to right or right to left. Okay. So for the multiplication and division group, the associativity is left to right. Okay, that is, the operators are evaluated from left to right. That is, first the leftmost operator will be evaluated and so on. Okay, so in this case the leftmost operator is division, right? So a divided by 4 will be first evaluated, so 2, and then multiplication into 2, 4. So correct answer is 4. Okay, so for evaluating a given C expression without any ambiguity, we require both the precedence rules and associativity rules. Precedence rules assigns a precedence level to each operator, okay, and associativity rules assigns the order to a group of operators which are at the same precedence level, and that associativity order is either left to right or right to left. Okay, so in this slide, the precedence levels and the associativity rules are specified for the common mathematical operators. Okay, now consider the examples. Okay, so 7 plus 3 into 6 divided by 2 minus 1. Okay, now this expression involves sum and multiplication, division, and minus. So multiplication and division has the higher precedence over plus and minus, so they will be evaluated first. And which one will be evaluated first? So multiplication is at the left of division, so associativity is from left to right, so multiplication will be evaluated first. Okay, so the equivalent expression using the parenthesis is this. Okay, so 3 into 6 will be evaluated first, and then the division will be evaluated next, and after that we have sum and subtraction left, and both of these operators are at the same precedence level, so we will use the associativity rules, and plus and minus are both left associative. Okay, so plus is at the left of minus, so this plus sign will be evaluated next. Okay, so you can see these brackets, and in the last the subtraction, that is this minus sign, will be evaluated, right? And similarly for this expression you can find the correct expression. Okay, for the next expression, a plus b plus c. Okay, so the order of evaluation will be, that is, the first sum will be evaluated first because sum is left associative. Okay, and then for the last expression, a exponent, b exponent, c. Okay, exponent is right associative, right? So it means that the right exponent will be evaluated first. So b exponent c will be evaluated first, and then the first exponent will be evaluated. Okay, so to correctly evaluate a given C expression, we need both the precedence and associativity rules. Okay, so operator precedence provide rules to specify unambiguously which operations, operator and operands, should be performed first in the given expression. So, and how this is done? We assign precedence labels to the operators that exactly identify the order of execution of those operators. Okay, so the expressions or sub-expressions with the higher precedence operators are evaluated first, and if the precedent labels are same, then associative rules are used for evaluation. Okay, so this is the general guideline for evaluating a C expression using the precedence and associativity rules. Okay, however, parentheses take the highest precedence and operation perform from the innermost to the outermost parenthesis. Okay, so if a C expression has all the necessary parentheses, then there is no need for the precedence and associativity rules, right? Because the parenthesis has the highest precedence. Okay, So for example, consider this expression 20 divided by 4 plus 6. 4 plus 6 is within the bracket. Okay, so whatever expression or sub-expression is specified within a parenthesis will be evaluated first, because parenthesis has the highest precedence level. Okay, so 4 plus 6, it will be 10. So 20 divided by 10, 2. So 2 is the correct answer. Okay, but if you write this expression without any parenthesis, okay, like this, then so division has higher precedence over plus. So 20 divided by 4, that is 5, plus 6, 11. In this case, uh, the, uh, the output will be 11. Okay, but if you write this expression with parenthesis like this, the output will be 2. Okay, so parenthesis has the highest precedence. Okay, so this table shows the various operator of the C and their description. Okay, their meaning and description, and their associativity. Okay, so there are okay, and each you can see that in each row in this table has several operators. Okay, and all those operators are at the same precedence level. Okay, so for example, the first row has these 5 operators. Okay, and these operators are at the same precedence level. In fact, these operators has the highest precedence. Okay, and then comes these operators which are specified in the second row of this table. Okay, they are at the next precedence levels, and all these has the same precedence level. Okay, and the associativity is specified over here, right to left. Okay, so you can see here that the parenthesis, left parenthesis, is among those operators which has the highest precedence. Okay, postfix increment and postfix decrement has also has the highest precedence. Then at the next level we have the prefix increment and decrement. Okay, this typecasting, we will discuss typecasting very shortly. So typecasting also has also is among the highest precedence level operators. Okay, typecasting is above the multiplication and division and summation and subtraction. Okay, so you can go through this table and find the exact precedence levels of each operator. Okay, so these are the common mathematical operators. Okay, and then these are the bitwise left shift and right shift. The associativity is left to right, and then comes the various comparison operators. Okay, then relation equal to or not equal to. After that we have various uh, logical operators. Okay, bitwise and bitwise exclusive or bitwise inclusive or logical and logical or. And then we have ternary operator. Okay, and then we have assignment operator. Okay, assignment operator means uh, it means that, say, whenever you have some expression like this, a variable a is equal to some expression. Okay, so first this expression will be evaluated, and after the evaluation of this expression is complete, the value will be stored in the variable specified at the left of the assignment. Okay, the comma operator has the lowest precedence level. Okay, now type conversion is also called typecasting. So type conversion is a method to convert a variable from one data type into another data type. Okay, in an expression, all the operands must be of the same type. If in an expression, an operator has different operands, that is operands of different types, then those operands must be converted into the same type so that the operator can be executed. Okay, so this conversion is known as type conversion or type casting. Okay, so consider this example. Okay, in this C code, here you can see that two integer variables are declared. Okay, sum initialized to 70 and count is initialized to 5. Okay, another variable mean is declared of type double. Okay, and the value of mean is assigned to this expression. Okay, double sum divided by count. Okay, first consider this portion of this expression, sum over count. Sum and count are both of type integer. Okay, so this division is basically integer division. So if you divide 17 divided by 5, okay, and this division is integer division, so the output will be 3. Okay, so because you are performing integer division, the output is 3. Okay, but say you want, because you are collecting this output in the mean variable and the type of the mean variable is double. Okay, so it means that you want some values after the decimal place. So if you divide 17 by 5, the correct result is 3.4. So it means that you must convert this output, that is the output of sum over count, into a double. Okay, and so how can you do that? You can use type conversion, typecasting, and the method to perform the typecasting is this, that is, just before the expression you write this expression, that is within the small bracket you write the data type you want to convert your expression into, right? So the sum over count, okay, this value will be uh, in fact what will happen, that is now this expression has two operators, the typecasting operator and the division operator. Okay, so when we have multiple operators in our expression, we must use the precedence level. Okay, so the typecasting operator comes in this group and the division comes in the next group. It means that the precedence of the typecasting is above the division. Okay, so first typecasting will be performed and then division will be performed. Okay, so double sum, this expression will be evaluated first. So now sum is of type integer, but now it will be casted into the double. Okay, so after typecasting, the 17, that is the value of sum, will become 17.0, right? Now it has been converted into the double data type. Now division will be performed. 17 divided by count value is still 5, integer. Okay, so the output will be 17.0 divided by 5. So it comes out to be 3.4. Okay, if you don't perform typecasting and you directly store sum over count in the mean variable, then your output would be 3.0, right? So in this situation, you may use typecasting. Okay, typecasting is of two types: implicit typecasting and explicit typecasting. Implicit typecasting automatically perform when a value is copied into compatible types. Okay, so what are the compatible types? Okay, we will see the list of the compatible types in the next slide. So in the implicit typecasting, no explicit operator is used. Okay, that is, a data type is implicitly converted into another data type. Okay, and obviously those two data types are compatible. Okay, and in the explicit typecasting, explicit type an explicit typecast operator is used to force the conversion. Okay, this example is the example of explicit typecasting, because we are forcing the integer variable sum to be converted into the double data type. Okay, so this is an example of explicit typecasting. Okay, And the syntax is this, that within the parenthesis we write the type name, and then comes the expression. Okay, so this expression can be a single a single variable, or any expression involving any number of variables and operators. Okay, so implicit data type. C automatically converts any intermediates values to the proper type so that the expression can be evaluated without losing any significance. The usual rule is that is the lower type is automatically converted to the higher type. Okay, so what is lower type? Okay, that the type which the size whose size is smaller is the lower type, and whose size is larger is the higher type. So for example, integer and float. The size of integer is 2 bytes, and the size of the float is 4 bytes, right? So the integer is lower type and float is the higher type. So integer is automatically converted into the float type. Okay. Likewise, float can be automatically converted into the double. The size of the double is 8. Okay, so double is higher than the float, so float is automatically converted into the double. Okay, it means that when you perform, say, c is a variable, say, okay, and c is equal to 4 plus 8.0. Okay, so 4 and 8 are constant. This is integer constant, and this is, say, a float constant. So this will also be, that is the 4 integer will be converted automatically into the 4. It will become 4.0. Okay, so conversion always happens from low data type to high data type. Okay, in the implicit data in conversion, the it happens from low data type to the high data type, so that information is not lost. Okay, so if you convert integer into float, no data will be lost. Okay, but if you convert floating variable into integer, then some data will be lost. Okay, so for example, say d is equal to, okay, d is equal to 8.2. Okay, and type of d is int. In this case, you are storing a floating number or double number in an integer data type, right? An integer variable. So this decimal part will be lost, right? So in the implicit typecasting, conversion happens from low data type to high data type, so that no information is lost. And this is the conversion hierarchy. Okay, that is, the conversion may take place from the lower data type to the higher data type. The lowest level in the hierarchy is short, and the highest level is long double. Short can be converted without any information lost into int, and int can be converted into unsigned int without any information lost, and then into long int it can be converted into unsigned long int, into float, and float can be converted into the double, and double into the long double, right? So any data type can be converted using the implicit typecasting into any data type which is at the higher level. Okay, so int can be converted into the long int, int can also be converted into the float, int can also be converted into the double or the long double, right? So this is implicit typecasting. Now explicit typecasting, sometimes we want to force a time conversion in a way that is different from automatic conversion. Okay, so the process of such a local conversion or casting is known as explicit type casting. And syntax is, in fact, we have already discussed this. Within parentheses, we write the type name in which we are going to typecast, and then the expression. Okay, so expression may be a constant, a variable, or any expression involving several variables and operators. Okay, now an example. In this example, we will see both implicit and explicit typecasting. Okay, so we have two variables of type integer, sum initialized to value 47, and another integer variable n which is initialized to 10. We have average variable of type float. Okay, then average is equal to sum over n. Okay, then printf, that is print result of implicit typecasting, okay, a float value and the value of the average. Okay, and then we evaluate the value of average again. Now we are performing explicit typecasting. Float sum, that is the type of sum is converted explicitly into float, and same is done with integer variable n also. Okay, that is its type is forcefully converted into float. Okay, and then the value of average is printed. Okay, then this program returns. Okay, now in the first expression, average is equal to sum over n. No explicit typecasting is used. Okay, so since both sum and n are of type integer, so integer division will be performed. So 47 divided by 10, so integer division is being performed, so output will be 4. Okay, and since we are storing this 4 in the average variable and the type of the average is floating point number, okay, so that 4 will be converted into the floating point number 4, so output will be 4.00, not 4. Okay, if you store sum over n, if you store the value of sum over n in some integer value, the output would be 4 without any decimal. Okay, but since we are storing we are storing the value of sum over n in the floating point variable average, the output is 4.000, right? Now consider the second expression, average is equal to float sum over float n. Now both sum and n variables, which are originally integer variables, are typecasted forcefully into the floating point number. Okay, so the precedence of typecasting operator is greater than division. So both sum and n are typecasted into float first. So they will become 47 divided by 0, 10.0. Okay, 47.0 divided by 10.0. Now a floating point division will be performed. Okay, and the result will be 4.7. Okay, and it will be stored in the floating point variable average, and the value is printed. So output is 4.7. Okay, so this is how the implicit typecasting is different from the explicit typecasting.